So we're faced with this seemingly large circuit and we're asked to simplify and redraw it and solve all the voltages and currents. Wow, where do we start? We've got a 20 volt battery source over here. We've got, I don't know how many resistors, I didn't bother counting them, but there must be more than one series and parallel circuit in here, and the aim is now to try and identify those different parts of the circuit and make individual loops. And to do this, I go back to something that I learned many years ago about using my favourite things, and that is coloured pencils. And if I can identify loops on here, then I can use different colours for the different loops. So I can identify one loop already from the 20 volt battery positive through the 1K, 28 ohms, 33 ohms, 1K back to the battery. So I'm going to colour that in red. Look at that, just plenty of red ink all over the paper, so to say. And there's one series branch of my circuit done, one loop if you like, done. And maybe we can even write on there loop number 1. Now, can I see another loop? Maybe I can use a different colour for this. Maybe I can use a blue. I can see a loop up through the, yeah, why not? Up through the 56 ohm, 47 ohm. How are we going here? Let's see. Ooh, I can see 1, 2, 3 resistors in series across the 72 ohm resistor. I like that. I'm going to colour them in blue. These are pretty rough and ready pencils, but they do the job. I think I got these from a yard sale, and I knew they'd come in handy one of these days. Here we are, look at that. So, ooh, all blue. I'm going to call that loop number 2. So that loop I can see is going to be quite easy to redraw. That's going to be a 72 ohm resistor between like points A and B, and then 3 resistors in series which are in parallel with that. So that'll be 82 plus 91 plus 68 in parallel with 72. So we'll redraw that shortly on another piece of paper. Meanwhile, continuing with that, yes, I can see another loop on the page. Can you see it? I can see a loop coming from the battery up through, ooh, that's a dark green, up through the 56 ohm, down here, down through another 56, over here, up here, 100 ohms, 22 ohms, into that blue loop number 2 that we just identified, and then back out of there, through that 47, down through here, up through here, and into here. Ooh, so I'm going to call that loop number 3. So I've been able to identify 3 different loops to work with on the paper here, and from this now, I mean, trying to look at that like you wouldn't want to be dyslexic because you'd just be totally dizzy and shocked. I think the easiest way to tackle this is to do exactly what the question says. Simplify, and maybe by redrawing it, simplify this, and then go ahead and solve all the voltages and currents in the circuit. So let's see if we can do that. Just take this piece of paper off for a moment. In this first loop here, in red, I've got 1, 2, 3, 4 resistors. I'm going to break that down into 2, and I'm going to do that by combining the 1K and the 33 ohm and the 1K and the 28 ohm. I think that's the best way to tackle this, and then still come out with one common point. So let's do that. That will be then 1033 ohms coming out of the negative, and 1028 ohms coming out of the positive, and those two join. So that's my first loop 1, and we used red on that before, so we'll use a number 1 on there, and again that is that red loop that we had on the other piece of paper. That's that red loop. Done. The second one that I'll do was, remember number 2? Number 2 here had 4 resistors, 3 which were in series, and they were all in parallel with the 72 ohm. Well, we need to run the figures on that, so we're going to have 68 plus 91 plus 82. Let's just see what that is. 68 plus 91 plus 82, 241 ohms, and that's going to be in parallel with the 72 ohms. And if we do 241 in parallel with 72, we'll have 241 times 72 divided by 241 plus 72. So 313 on the bottom, and 241 times 72, 17,352 on top, divided by that 313, and that gives me 55.4 ohms. So that's that loop number 2, and what I might do with that is to, we used blue for that loop number 2 before, so maybe I'll just get the calculations that I did here and use a nice blue pencil to highlight that, and then write the number 2 in that loop there. So there's the calculations for, like, that should be I suppose written as REQ. So that'd be the equivalent resistance for that particular part of the loop there, 4 resistors together. And going back to the circuit again, now we get into the green loop, and we've got the 56 ohm and 47 ohm in series. So that's going to be, what's that, 90 plus 13, 103 ohms. 103 ohm resistor, looking for the texter, 103 ohm resistor coming from here, 103 ohms. I can get the green and go over that in green, because that represents this 56 and 47 here. And then the blue number 2 loop had a REQ of 55.4 ohms, so I'll add that in series with that. .4 ohms, and keeping the same colour schemes. Ooh, he was blue, so we need to put blue for him, just to remind us that he was loop number 2. I think I need to get a sharpener and sharpen these poor old crayons up a bit. And then coming out the other side of loop number 2, coming out the other side, because we're at this point here, coming out the other side, we've got 22 plus 100, that's 122, plus 56 is 172, 178 plus 56, 178 plus 56, 226 ohms. Ohms, and that comes back around into the battery like that, and of course that is part of that green loop there. So the green loop was loop number 3, part of loop number 3. So loop number 3 encapsulates loop number 2. Okay, tiny little mistake there. You can see I've just used the correction, whatever it is, tape. How can I make such a bad mistake? 234 ohms. 234 ohms we have there. So we've really simplified the circuit down now. We've just got 3 resistors in series, 1 resistor to this point here, 1 resistor to this point here. So really these 3 resistors which are in series, the resistors which comprise loop 2, the resistors which made up loop 3, now we just have to add those together, and they're going to be in parallel with the 1028 ohm resistor. So let's do that. The 234, another pen for that, 234, let's hope we don't make any more silly mistakes. That's why we use a calculator. 55.4. Add 103 ohms to get 392.4. Is that right? 9, 12, 392.4. Then we've got the 392.4 in parallel with the 128. So the best way to do that would be using the sum of the conductances. So 1 on 392.4, add 1 on 1028, and then 1 on the whole lot of that. And that's going to be equal to, grabs the brain box, and do the things very quickly. And that's going to be 284 ohms. Again, that's a equivalent resistance, 284 ohms. So maybe we could even put a new loop around that on the circuit just to identify what we've done now. So using yet again another colour. See how versatile these pencils can be. And that REQ, 284 ohms going down through there. And then looking at the circuit and maybe having almost what's a final redraw of this in the simplification process. Again, our battery, and we didn't label that, it wasn't necessary then, but we're getting closer to needing that 20 volts now. 20 volts, and we've got that REQ 284, and then we've got 1033 ohms, 284 ohms, and we can add those together to get 1317. We've got the calculator now, we're not going to make any more mistakes. I hope. 1317. So RT equals 1317 ohms. IT IT is going to be equal to 20 volts divided by that 1317. And that's going to be equal to 15.18 milliamps flowing in the circuit. Alright, are we there yet? No, we're not, because the question did say to simplify and redraw this and then solve all the voltages and currents. Well, we've certainly simplified and redrawn it, and that was only the first step to get the overall current flowing in the circuit, so that then I can work out from that some branch currents and some resistor voltages. Just looking at that and seeing if I can in fact solve any of those resistor voltages. Well, this 1K and 33 ohm now, I know the current flowing through them because they're in series with the overall loop. So certainly I'd be able to put a value of current across those, and that value of current would be what we just worked out there, which is 15.18 milliamps. Alright, it's time then to do some yet more redrawing, because I know what the total current is in this network. I know that I've got a total loop current there of 15.18 milliamps. But I need to know then what the loop current is going to be, or the branch current in each one of these. So forgive me for drawing the arrows. Oh no, we'll draw the arrows the other way. We'll work in conventional. This particular circuit lends itself to drawing the arrow from the negative and saying I've got one branch current there and I've got another branch current there. But we'll go this way. Why not? What the heck? So I've got one current flowing through the 1028, and I've got another current flowing through the 55.4, and both of those branch currents have to add up to 15.18 milliamps. So let's quickly redraw that. Here's our battery again, and we've got, whoops, come on a bit higher there. $234, and this one was 1028. This one came down through 55.4 and came along through 103. Then we hit a bit of 1033 down here, and that one, woo, back down there like that. Alright, putting the currents back on the circuit. So we had 15.18 milliamps. We've got a current divider situation happening here, and the current divider says that we need to get the REQ divided by RX times VS. Whoops, I beg your pardon, times IS. Ooh, let's fix that up. IT. So the REQ there was 284 ohms. Keep the same colours that I had. That's 284 ohms. REQ. Oops, we took one out of the loop. 284. No, it's not. That's 392. That's this loop here. Ooh. You can see how easy it is to make some mistakes on this, especially with live videoing, but it's alright. That's what this magic tape's for. We can fix things up on the fly. Nothing like a bit of a repair job. So that 284 ohms REQ is all of that loop together, and we're working out the individual currents based on the individual resistances. So that'll be 284. So case 1 be 284 divided by 234 times 15.18, and case 2 it'll be 284 divided by 1028 times 15.18. So I'll just go ahead and work those out. Okay, we've done it again. 284 divided by... Ah, dear. As soon as I wrote that down, I should have realised that wasn't right. Remember, that was 234 plus 55.4 plus the 103, and that added up to 392.4. So, working that out, 284 divided by 392.4 times, might as well work in whole milliamps, 15.18, 10.98 milliamps. So case 1, 10.98 milliamps. And then of course we could subtract that from the 15.18 milliamps to get the case 2 current, but we'll go ahead and do the equation anyway. So it'll be 284 divided by this particular part of the network, this branch of the network, 1028, and then times 15.18 again in whole milliamps to get 4.19. 19 milliamps, and you can do a check. The 4.19 milliamps, we can add them together, add to 10.98, and that'll add to 15.18 milliamps that we got there. So that's correct. So we now can put some values on the circuit. We've got through the top bunch of resistors here, we ended up with 10.98 milliamps, and this inside loop here we ended up with 4.19 milliamps. Flowing down through those, and of course the current over here being 15.1 milliamps going that way. And then we're almost ready to be able to put some voltages on different resistors here. I'd have to go back to a slightly larger circuit then to do that, because I've dramatically reduced things down to get the circuit to this stage where I can work out individual branch currents, the total current, individual branch currents. I did that by collectively grouping all of those components together with different colours there to make it easy for myself, and especially if I was going to breadboard this up, goodness, I'd always be drawing what I was going to do on like a blank of a breadboard on paper, and I'd be mapping it in colour, saying exactly what loop was going to be where, because it's so easy to make a mistake. So we went from the large circuit here, which looked almost impossible to do anything with. We've simplified by redrawing. We still haven't solved all the voltages, but we've certainly solved the bulk of the currents. We have to break down loop number 2 still and work out the current going through 3 of the resistors and the current going through the 72 ohms. And that was in that green loop 3 and 2, and we had the REQ for that. That was the loop 3-2 and the loop 3-2. The REQ was 391 ohms, and we worked out the current based on that loop, and that current worked out at 10.98 milliamps. So again, I could work with that REQ of that loop now, and I could work out the branch currents as they split in this loop as well. Not too hard when you know how.